so so with the zero initial value, we have only the SL value. SL means in the frequency domain. Apart from that, if you will take a Thevenin to Norton, because this is Thevenin to Norton, you can see here S for the inductor is parallel with the current source. Current source value is I naught by S. If initially the I naught is zero, it is become zero, and if the current value is zero, it is become open circuit. So only you have between the terminal A and B S L value. So that is the reason actually we have to consider our I naught value. And I naught is very I naught every time we have to define as a initial. Apart from that, if you will see the capacitor in the time domain IV relation, that is I of t c multiplied by d by dt v of t. So here that is, if you will take the Laplace, that is Laplace of I of t is become I of s equal to C S Vs minus V naught. Here again, the previously for the case of inductor, we have a current. Now here, in the case of capacitor, we have the voltage, and this is called the initial voltage. So SC multiplied by Vs minus C into C into V naught. Again, we have to define that C into V naught in the equivalent circuit model. How to define? You can see here when the capacitor is connected parallel with the current source when C V naught. So when the V naught is zero, this complete is zero, and current source is zero, it is become between the terminal A and B 1 by SC. What is the meaning V of zero? When the initial voltage is zero. For this case, for the case of the second case, when we are taking the voltage source into the series. So if initially the voltage is zero, so the total voltage source is zero, and it will become short circuit, and we have between the terminal A and B we have 1 by SC. So for example, we will take one example assuming the zero initial condition. So you can see the circuit which is having the input as a U of t, which is connected with some lambda element, and output we have to calculate V naught of t. If you closely look, this entire circuit is in time domain. Okay, and we have to apply the Laplace transform in this circuit. So when we are applying the Laplace transform for this circuit, so you can see our source U of t is become 1 by S as per the property. Yeah, 1 ohm resistor, it is a resistor, so there is no change in the resistance value. 5 ohm is the resistance, it is no change in the 5 ohm value. 1 by 3 farad, 1 by 3 farad is 1 by SC, or we can write 3 by S, or 1 H is become SL, and we can write as S. Based on this all the values, we can draw the new circuit. So our new circuit is become, you can see the voltage source is 1 by S. So this circuit is in now frequency domain. Then 1 ohm resistor, 5 ohm resistor, and then we have a 3 by S capacitor, then S. Our main focus is on V naught of S. So we can simply use the method that is called mesh, because we have a lot of methods. We can use here the node also, we can use here the mesh also, whatever method you know you can apply here. So when we are applying the mesh, so we have a two meshes here, I1S and I2S. So for the mesh one, we will get one equation. For the mesh two, we will get one equation. Okay. So how to get that one? For this applying the mesh, it is 1 by S. We have to see the polarity. The polarity is positive, 1 by S. After that, the same current is flowing through that particular what resistor. So again we have to apply the Ohm's law. So I1 multiply by 1. Okay, then 3 by S multiply by I1. So you can see here 1 is multiplied by I1, and 3 by S multiplied by I1. At the same time, if you will closely look, the I2 current is also passing through the 3 by S, but in the opposite direction. So for that case, minus times of 3 by S I2. Okay, so this is the equation for mesh number 2. The similar way we can write the equation for mesh number sorry, this is the equation for mesh number 1, and similar type we can write the equation for mesh number 2. So after from the mesh number 1 and mesh number 2, we will get a value of I2. This I2 is 3 divided by S cube plus 8S square plus 18S. Now the thing is, this I2 value is in frequency domain. Okay, The I2 value is in frequency domain, but our main focus is on V naught of S. So this I2 value is passing through this V naught of S. So the what is the value of V naught? V naught value is S multiplied by S I2, correct? V naught is S multiplied by I2. So the V naught is equal to 3 divided by S square plus 8S plus 18. So now you can see the V naught is 3 divided by S square plus 8S plus 18. So if we will go for partial fraction, we can write 3 by root 2 multiplied by root 2 S plus 4 whole square plus root 2 whole square. Now easily we can apply the inverse Laplace transform, and that will comes into the form of property, the Laplace property. So finally, our this when we are taking the inverse of V naught of S, it will become V naught of T, and root 2 divided by S square plus 4 whole square plus root 2 whole square, it will become e to the power minus 40 sine root T, and this value is T is greater than 0. Correct? This T is greater than 0. So finally, we are doing the solution for the case of Laplace with zero initial condition. Right? So here, the what is the meaning of zero initial condition? The meaning of zero initial condition means the when we are converting from time domain to frequency domain. If we will go to the previous slide, okay, when we are doing the solution in time domain to frequency domain. So in the frequency domain with inductor, you will get here the voltage source, but due to the I naught value is 0, the initial value is 0, only you will get the inductor. So the same thing we have placed here when we are converting to our circuit to the time domain to frequency. So likewise, actually we have to do some sort of solutions. One more example, find the V naught of T in the circuit. Assume V naught of 0 is 5 volt. What is the meaning V naught of 0 is 5 volt? The initial value is how much? It is a 5 volt. Okay. So now let us we will do the solution. So if we will closely look, this particular circuit is in time domain. So now the thing is we need to convert this time domain circuit to the frequency domain. How to convert time domain to frequency domain? If we will see, so 10 e to the power u of t, 10 e to the power u of t is become 10 by s plus 1. Okay. Then 10 ohm is same. 0.1 farad is become 10 by s, and we have a 2 del of t. 2 del of t in the time domain, the frequency domain is 1, so we can get a 2 ampere. But one more thing, because we have the v naught of 0 is 5 volt initial, so with this capacitor we will add one more current source that is in the parallel with the capacitor, and that value is 0.5 amperes. Correct? That value is 0. After that, we can easily do the solution. Fine. So now we can apply the nodal here for the particular circuit. So 10 by s plus 1 minus v naught divided by 10 plus 2 plus 0.5 equal to v naught by 10 plus v naught by 10 divided by s. Okay. Now we will do the further solution. We will get here the v naught in terms of the a by s plus 1 plus v by s2. This is called as a partial fraction. Now we have to calculate the value of a and b. After doing the algebraic method, we will use we will get a is 10, b is 15. Now we will put the a value 10 by s plus 1 and plus 15 by s plus 2. So, but this solution is in frequency domain. We have to take an inverse Laplace. Then after taking the inverse Laplace as per the property, that is 10 s plus 1 is nothing but 10 e to the power minus t u of t, and 10 divided by s plus 5 is nothing but 15 e to the power minus 2t u of t. And this solution is again in the frequency domain. So the conclusion is very simple. When you have an initial which is point which is we have to remember, the initial value has been given, and this for the capacitor, for this initial value we have a two method. Either we can use the voltage source as per the circuit demand, we can use the voltage source, or we can use the current source. For both the cases the solution is same. Okay, so but for the simplicity we can use here the current source. Okay, so we will get a solution very easily. Okay. So this is some sort of example which is I'm taking into the case of mm, with zero initial conditions. Okay. First of all, we have to solve some problems with. So for the zero, if you have a question related to the zero initial condition, easily you can solve your circuit, convert to time domain to frequency domain, and you can do to use the some sort of method, mash, note, and superposition. Okay, and you can do the solution. So based on that, I will take one quiz for this case. Then you have to solve a problem, and after that, I will evaluate this. Okay. Thank you very much.